Good morning and welcome to day number 20. I think this is going to be the final lesson from chapter 9. Nothing too technical here, just kind of wraps everything up that we've been talking about for the last 2 weeks or so. So we're going to skip section 4 and kind of move on to section 5, which is more or less just kind of a summary of what we've been talking about in the last two chapters. So going back, the localized electron model is this idea that when there is a covalent bond, this covalent bond is basically sharing electrons between two adjacent atoms, okay? And when drawing Lewis structures, oftentimes we realize with more complex molecules that there can be more than one correct diagram. And I think a good example of that would be ozone. If we were to do the structure for ozone, we could come up with actually two possible structures. And, whoops, basically we could do the mirror image of this, which would also be appropriate. So we could have the double bond on the left, or we could have the double bond on the right, but regardless, there would be two correct structures for ozone. Okay, and resonance kind of deals with this localized electron model. Sigma bonds can be thought of as kind of adhering to the localized electron model. And pi bonds, on the other hand, pi bonds is kind of caused by the side-on overlapping of orbitals. This is kind of more of the delocalized model or the molecular orbital model. So pi bonds can kind of be thought of as existing within a whole molecule or within a large group of atoms inside of a molecule. And the example I'm going to show you here in just a minute is benzene. So benzene is a hexagonal structure, and it's commonly used to describe this localized electron versus molecular model. And if we kind of look at it as kind of a hexagonal plane, and there's 6 carbons in a ring, all of those carbons are really identical. So if we look at the structure for benzene, it kind of looks something like this. Now, if you wanted to draw it, I'm going to kind of simplify for you here. You could show it as a series of double bonds and single bonds. And keep in mind, there would be a hydrogen sticking off of each one of these hydrogens. And if you wanted to do the resonance structure, you could basically alternate where you place those double bonds. Okay, well, this idea of the localized electron model describes that the first bond formed between all these carbon atoms is going to be a sigma bond. So your sigma bonds, basically the head-on overlapping of these hybridized sp orbitals, and those are the first ones to form. But if you kind of look at the second diagram, now we see these p orbitals that are kind of side-on overlapping, and this diagram shows all the pi bonds. So sigma bonds caused by the head-on overlapping, the sigma bonds can be kind of thought of as following the localized electron model. Those electrons are shared between two carbon atoms. But when you look at the pi bonds that form these double bonds, these bonds actually exist throughout that entire ring structure. Now, hydrogen is really not part of that structure. Hydrogen kind of sticks off the outside of the molecule. But if you look at this 6-carbon ring, these pi bonds that really form a molecular orbital that is sort of like a racetrack that runs around this 6-carbon hexagonal structure. So this is going to be the last lesson from chapter 9. You guys will have a few questions. You might have to dig back a little bit into some of your previous chapters. They're just kind of general questions that sum up everything that we've been talking about bonding. Don't be surprised if I slip some questions about ionic bonding or metallic bonding in there. But if you guys do have any questions, feel free to send me an email, or you guys can leave a comment on Google Classroom. I miss you guys. I love you guys. I'll see you soon.